This Unreal Engine 5.5 door requires the FGameplayTag Access.Key.Red. The credential begins with only access key blue, so the first exact tag query fails and the door turns red. 1 second later, C++ adds the required red tag to the same container. The second query succeeds, the door turns green, and it opens to 90 degrees. In this lesson, we will register tags in project configuration, request native tag values, store them in an FGameplayTag container, use HasTagExact for authorization, update the container at runtime, and verify the entire deny to grant transition with real frames, exact logs, and automation. Gameplay tags are hierarchical names registered with Unreal's Global Tag Manager. This project imports 2 native entries from default GameplayTags.ini, Access.Key.Blue and Access.Key.Red. The module also adds gameplay tags as a build dependency. Registration matters because FGameplayTag is not an arbitrary string wrapper. Request gameplay tag resolves a known name to the engine-managed value and can warn when code requests an invalid tag. Central names reduce spelling drift and give C++, Blueprint, Assets, and Editor tools the same vocabulary. The doors requirement is one FGameplayTag, Access.Key.Red. The credential owns an FGameplayTag container because an object can have several capabilities, states, or classifications at once. A container supports adding, removing, matching, filtering, and replication-oriented workflows without hand-maintained Boolean fields such as has_red_key, has_blue_key, and has_admin access. Tags describe meaning. The object that owns gameplay state still decides when those meanings are added or removed. During begin play, the credential requests Access.Key.Blue and adds it to own tags. The container now serializes and reports one exact tag. The door independently requests Access.Key.Red as its requirement. Neither actor needs a pointer to a specific key class or an enum shared with every future access rule. They communicate through registered semantic values. The runtime log records both names before the first attempt, which lets us prove the presented data and the required data were different. The door calls HasTagExact on the presented container with its required red tag. The blue-only credential returns false. The result is access denied, the panel turns red, and no opening state begins. Exact matching is deliberate. Gameplay tags are hierarchical, so HasTag can include parent-child matching, depending on the query. Use exact matching when only one precise tag grants permission. Use parent or query-based matching when a broader category, combinations, exclusions, or more expressive rules are intended. 1 second later, the credential adds Access.Key.Red to the existing container. It now owns both blue and red. The same try-access function runs again with no door-specific special case. HasTagExact returns true, the result becomes granted, and the door starts its private hinge animation. This is the data-driven benefit. Behavior changes because semantic state changed, not because the caller selected a different function or concrete door subclass. These are real game mode frames from GameplayTag demo map. First, the blue credential presents only Access.Key.Blue and the closed door reports access denied in red. After the red tag is added, the credential turns green and the door reports granted, opening 50%. At completion, the doorway is clear at 90 degrees and the status reads access open. The visible transition comes from the same exact tag check recorded in the runtime log. Automation first confirms that both configured tag names resolve to valid FGameplay tags. It proves a blue-only container fails the red requirement, a blue and red container succeeds, and the door angle remains exact at 0, halfway, completion, and after completion. Runtime then records match false and result denied, the added red tag, match true and result granted, a 90-degree door, both own tags, and valid true. The test passed with 1 success and 0 failures. The reusable pattern is 4 steps. Register stable names centrally. Request or declare those tags in code. Store semantic state in an FGameplayTag container. Query with the matching rule your design actually needs. Gameplay tags work well for abilities, damage types, equipment categories, quest state, access rules, status effects, interaction traits, and AI classification. Keep ownership and transitions explicit, document hierarchy, and test both positive and negative cases. Tags make systems share vocabulary. They do not replace the gameplay code that responds to that vocabulary.